for your modern cloud. First of all, I'm super excited to be here, and I'd like to thank the entire OMH organizers and the entire team for setting up this amazing conference. Right, so I am a little bit ambitious in terms of what I want to cover today. So I have prepared for a lot, and I actually do have 4 demos towards the end of the entire session as well. Right, so I want to go ahead and showcase that. But before we get started, a little bit about myself. So I am a senior research officer and a lead trainer at appsecengineer.com. And I also work at P45 as a senior solutions engineer. So my journey essentially started off as a DevOps engineer, and I got involved with security. And eventually from there, due to my background in automation and DevOps, I eventually migrated to DevSecOps, and I helped multiple clients of ours in multiple organizations implement a DevSecOps successfully. Right. So I am also a co-lead developer at Threat Playbook and Orchestration. So these are open source projects. And at the same time, I am also a trainer and a speaker at multiple security events. In fact, I will be training at Black Hat later this year, in a few months from now, on DevSecOps itself, right? So I'm going to be conducting the DevSecOps masterclass. So with that, let's quickly get started with the actual presentation itself. So when you really think about what the idea behind the goal of DevSecOps, it's essentially to go ahead and increase the throughput, and by decreasing the operating expenses as a whole, right? So you can essentially increase the throughput by ensuring that the applications that you're deploying to the cloud are going to be high quality, right? So with relatively minimal bugs and no security issues. So all of this is essentially going to ensure that you are essentially going to be delivering high throughput. At the same time, you want to go ahead and reduce the operating resources, right? So you want to ensure that you reduce the amount of time taken by testing. You want to reduce the overall time taken that it takes to essentially go ahead and fix what the issue is after figuring out what is actually going on. And at the same time, the last thing you want to be doing is firefighting issues on the cloud, right? So you do not want to be deploying your applications multiple times and that your application having to go down for a couple of minutes. That is the last thing that you want, especially when you're going to be on the cloud and if it's going to be a client-facing application, right? So the goal behind DevSecOps at end of the day is to go ahead and ensure that the application performance is as efficient as possible. At the same time, you want to ensure that the engineers, and we're going to be talking about security engineers specifically, they do not necessarily waste time by running scripts or by running automation scans, which can be completely automated, right? So security engineers at end of the day, they should be focusing on more things that require their expertise, like finding zero-day issues or finding business logic vulnerabilities that your typical tools cannot find. So when you think about the contributors to velocity for applications and the increasement in essentially deploying these applications, it pretty much started off with the introduction of microservices, right? So typically we were deploying all of our applications as monoliths, and then we started splitting all of these monolith apps into multiple microservices and started deploying these microservices using containers on Kubernetes clusters and even on serverless. And these days it's going to be on unikernels going forward, right? So if you really think about it, this has been a huge contribution, not only in increasing the velocity of the application, yet also ensuring that the application is constantly more up to date, and there are new features and additional features that are constantly being added as well. At the same time, we also have engineering tools, and we have multiple frameworks and also concepts which have now been compressed. And along with this, when you really think about deployment these days, all of it is mostly with infrastructure as code, right? So whether it's going to be your Kubernetes specification files, or whether it's going to be your serverless YAML files, or something like Terraform or Ansible, most of the times when you are now, these days, when you're going to be deploying to the cloud, it's not going to be point and click that we were used to probably a decade ago, right? So these days, essentially, we are writing our entire infrastructure or the desired state as code, and we're going to go ahead and deploy our entire infrastructure using code, like something like YAML specification files. And also continuous integration and continuous delivery has played a huge role in ensuring that the deployment of application and maintaining all of these applications have been really fast as well. So in case your folks are wondering what the modern stack is all about, right? So modern stack these days, at least the way I see it, is a lot more distributed, right? So previously it used to be on one server or a couple of servers with probably a HA proxy or some load balancer somewhere that used to manage the entire application. These days, however, you have serverless functions that now communicate with something like AWS Fargate, where the application is going to be running on EC2 instance and the files are being stored on S3. So it's a lot more distributed the way applications are working. And the entire functionality of the application is going to be a lot more distributed as well. And this relies extensively on the entire microservice style architecture, right? So especially with the introduction of container technology, microservice style architecture has taken off. And obviously, this has its own set of advantages, right? So it's a lot more scalable and a lot more flexible to go ahead and deploy an application in the entire microservice style architecture. If you want to go ahead and scale your application to thousands to tens of thousands of users in something like Kubernetes, it's literally one single command. Right? So it's that simple to go ahead and start creating replicas to ensure that you are delivering your application successfully for multiple users. At the same time, you also have the advantage of using multiple platforms or programming languages to go ahead and implement your entire stack itself, right? So if you have one function which performs well in Python and one more function that performs well in something like Golang, and both of these functions can communicate with each other, that's a great combination, right? So because you're not restricted to one single programming language anymore for your single application, you can now go ahead and start using Node.js, Golang, Python, and start essentially containerizing these services or microservices, and you can start deploying all of these microservices, and essentially they can all communicate with each other via APIs or any other service like that. So when you think about continuous integration and continuous delivery as a whole, right? So you have the entire planning phase, the coding phase where you go ahead and build a code, and then you obviously have a bunch of unit tests that are performed, and then you go ahead and spin up your entire staging environment on which you go ahead and perform a few live tests. And once all of these integration checks have been performed successfully, only then it's going to be deployed to your production environment. And then you go ahead and start monitoring your application in real time to see what is actually going on. But when you really look into it, whether it's in the requirement phase, the design phase, or the development phase, or towards or in the entire life cycle of your CI/CD pipeline itself, there is no security currently involved, right? So these days, it's a lot better than what it was probably 2 or 3 years ago. But security is still a key challenge when it comes to integrating it as part of the entire CI/CD cycle. So ideally speaking, you want to go ahead and start threat modeling in the requirements and the design phase. Right? So you want to go ahead and run static analysis and also something like a source composition analysis when your developers are actually developing your application. And probably in something like your testing phase, you want to go ahead and scan your application on the staging environment and run a few regression scripts if you'd like. And only then you can go ahead and deploy once all of these security checks have been implemented and all the security checks have been passed successfully as well, right? So security is going to be an essential component in the entire microservice style architecture because there are going to be constantly changes that are going to happen, not just on a daily basis, but on an hourly basis, right? So your applications are going to be updated and deployed on an RP basis, which is going to be extremely rapid. So you want to ensure that you are having security checks performed before you actually go ahead and deploy your application into production. So in short, the application delivery is sprinting forwards because the application delivery as a whole, it's a lot faster, right? So the developers are writing code a lot more faster due to the microservice style architecture. They do not have to worry about breaking the entire monolith anymore. And it's very easy for them to go ahead and start deploying all of these services as well. But if you now start thinking about application security is now trying to play catch up with the entire delivery of the applications because since they are going to be rapidly released and rapidly deployed, performing all of these security checks is going to be a pain because they typically tend to take a while, right? So if you want to go ahead and perform an entire full-fledged security assessment, of the application that's going to be deployed very soon, it typically tends to take a while. So application security is still playing catch up. So the need of the hour is to find and fix all of your security issues as early as possible, at the same time as often as possible as well. And you really will want to integrate security with the entire agile development process itself, right? So you want to go ahead and start integrating security into the multiple teams of the organization and have them involved as part of your entire security process to ensure that it is a lot more robust. And finally, you want security to seamlessly work with your continuous delivery pipeline, right? So I'm pretty sure most of us are aware that security scans tend to take a while. And one of the key issues with integrating security as part of the traditional CI/CD pipeline is the amount of time taken for it to actually go ahead and finish the build and then for it to be deployed into production, right? So what you'll want to do is start tuning all of your security scanners and ensuring that the entire security process is as compact and at the same time as efficient as possible. So when you look at the likely trends, developers are already consuming ops, right? So especially with what I previously spoke about, infrastructure as code, developers are already writing Kubernetes YAML specification files. They're already writing Terraform files, probably Ansible files, and serverless.yaml specification files. So developers are already kind of used to ops these days when it comes to infrastructure as code and using that to deploy the entire infrastructure on your cloud provider. And eventually, pretty soon, they're likely going to start consuming security as well, right? So integration is going to be the name of the game and not friction when it comes to developers having to go ahead and be involved with some amount of security. And you also want to start moving security from actually being a bottleneck, which it is at the present day when you really look at integrating security as part of a traditional CI/CD pipeline. You want to start moving it to be a part of the entire engineering process and probably even leverage that as a competitive advantage. And at the same time, you want to be effective, not just for speed, but or for scale. You want to be effective for combination of both, right? So you want to ensure that all of your security checks are being performed super rapidly. At the same time, you want to ensure that it's going to be happening across all of the microservices that are going to be deployed, right? So if it's going to be a combination of both of these things, then you can be pretty certain that the entire security process is relatively mature. So when you look at security in the entire DevOps pipeline, right? So in the planning phase, we obviously have threat modeling. Now, if you can go ahead and automate a few bits and pieces of threat modeling and combine them with the other results from your security tools, that's a great way to go about it. And in the coding phase or in the entire building phase of your application, you obviously have static application security checks and your source composition analysis scans as well. And in the testing phase, once your application is actually deployed to something like a staging environment, you can then go ahead and start running multiple DAST tools like OWASP or any other commercial tool as well. And once your application is actually up and running, then you can go ahead and start looking into infrastructure as code to actually ensure that the infrastructure that is deployed is secure. Because when it comes to infrastructure as code, the problems that I often see in the real world when I'm working with my clients to help them implement DevSecOps is misconfigurations, right? So although developers are great at writing infrastructure as code, some of them might not necessarily be security aware, which is where we as security engineers or the entire security team, we'll have to come in and help them implement and ensure that the configurations that they're using, especially in their infrastructure as code, is going to be a lot more secure and efficient. And once your application has been deployed, you can then go ahead and start operating it and start monitoring it for potential attacks and so on. But before I get started with the actual demos and actually talking about cloud native DevSecOps, right? So one of the problems that I often see in the real world is to do with the cultural aspects in the organization itself. DevSecOps is not going to solve all of your security challenges in your organizations. And unfortunately, that is what people expect. People expect, hey, you know what? Once I implement DevSecOps successfully, security is automated and taken care of. I do not have to worry about it anymore. And that is what actually people think in relatively large organizations, which is not going to be the case, right? So when you look at the ground truths or the realities and some of the common problems, people tend to have unrealistic expectations, especially when they're starting off with DevSecOps, right? So in the initial phases, DevSecOps is going to be a grind, right? So it's going to be hard to implement, it's going to be hard to maintain, but it is going to be worth it once you go ahead and reach a certain scale, and once you realize the entire cultural aspect of the organization of how the way the things should ideally work. And one more thing that we've often observed is security typically tends to work as a silo, right? So developers are doing their own thing, the DevOps folks are doing their own thing, and then the security folks are doing their own things, running security tests, performing great team activities, and so on and so forth. And they are not communicating with the other teams in the organization, which can be pretty challenging, especially if you want to go ahead and implement DevSecOps successfully. And one thing that people tend to confuse is continuous integration is not necessarily the same as continuous security, right? So typically when organizations, they start off with DevSecOps, they automatically want to go ahead and throw in a bunch of tools at the pipeline. They want the pipeline to run, the security scans to go ahead and run successfully, and done and dusted, right? So that is not how things would ideally work. Uh, when you're going to start implementing tools, one of the first issues that you are going to face no matter what is you're going to have to deal with false positives, right? So these tools are going to go ahead and start throwing issues, and these reports are going to be massive, and they are going to have a lot of false positives. And we'll be looking into how we can probably deal with that very soon. And they'll also want to start breaking the build. And if your organization is going to be relatively new to implementing DevSecOps, breaking the build is something that you're going to have to be extremely careful with, right? So it's not going to work very often. Only for mature DevSecOps teams, it will work wonderfully. But if an organization is just starting out, or if they're in the initial phases of implementing DevSecOps, it is going to be a challenge to go ahead and start breaking the build. Cultural issues before, you'll want to go ahead and fix them first before you actually go ahead and start throwing a bunch of tools at your CI/CD pipeline and wanting them to run successfully. And security tests are not the same as functional tests. In functional tests, you have clearly set expected conditions. Security tests is not the same, right? So there are going to be hundreds to thousands of potential attack vectors, and it's really going to be hard to go ahead and find out, hey, you know what, does this issue or this does something like SSRF actually exist in my application? Or does something like IDOR, insecure direct object reference, actually exist in my application? So in functional tests, you have clearly set expected conditions. With security tests, however, it is not going to be the same, right? So even though that you might have tested for something like IDOR, there might still be chances of a potential privilege escalation through some other attack vector, right? So those are some of the key challenges that you'll have to keep in mind. And if you deal with security separately and as not your responsibility, the organization is going to fail at DevSecOps pretty bad. So when it comes to unrealistic expectations, right? So a lot of these automations, they depend on the tooling, right? So go ahead and play around with a bunch of tools, implement a bunch of tools, and only then select the tool that you actually want to go ahead and implement as part of your DevSecOps pipeline. Like, just don't go ahead and take multiple tools and then throw it as part of your CI/CD pipeline. And you'll also obviously want to have to deal with false positives. This is where the confidence scores of the tool, how good the actual tool is, that comes into play. If your tool is good and it reduces the overall number of false positives, that's great. Go ahead and implement it. And at the same time, your security tests are not the same as functional tests, your regression tests, or your unit tests. Understand that everything may not even be running at your main build pipeline. So typically what I would recommend initially is to have a separate pipeline just for security, right? So do not go ahead and start integrating tools as part of your main build pipeline initially. go ahead, have a separate pipeline just focused on security and security tools, run it, maintain it, tweak it, see what the reports are like, see what changes you can go ahead and make to ensure it's a lot more efficient. Then cherry pick the tools or whatever that is that you want to go ahead and implement as part of your main pipeline, and only then go ahead and implement it. At the same time, you want to start having every engineering team involved as part of your security, right? So you want to go ahead and enhance and embed security, whether it's in threat modeling or secure coding practices, or even teaching developers about some of the top 10 issues when it comes to either something like web applications or infrastructure related security aspects. And you also want to start using automations to drive the entire security process as part of the engineering process itself. And ideally integrate with engineering workflows so that developers are going to be there so that they understand what it is they have to fix and go ahead and start fixing all of these issues. And finally, do not be afraid to give up control, because at the end of the day, it is going to be your responsibility as a security engineer or someone who's going to be part of the security team to ensure that the application that is currently in production is secure. So when it comes to integrating with engineering workflows, this is something you probably are used to, right? So you want to go ahead and start integrating security by either in Jira or GitHub or any other VSTS. You can also have separate Slack channels focused on security and start inviting people from other teams into the Slack channel so that they have a more clear view of what's actually happening. And you also want to bring security into the entire sprint planning with threat modeling before you actually go ahead and start building multiple functionalities of your application. And you want to let engineering run and manage the entire automation once you've implemented it successfully. And you want to also try and embed security into your agile test-driven development or anything else that you're using in your organization. Try and integrate security wherever possible. And finally, when it comes to breaking the build, right? So this is directly a function of quality of security checks. This is not going to be the goal or the aspiration of your entire DevSecOps itself, right? So this is not what you want to be doing initially. And if you execute this badly, the teams are going to lose faith in the entire security test and they'll want it removed from the entire pipeline itself. And this is something that I would typically recommend for extremely mature teams who've already implemented some parts of DevSecOps successfully. So when it comes to tooling, let's quickly talk about SAST, SCA, and DAST, and let's go ahead and start looking into implementing these in an automated fashion, right? So when it comes to static application security testing, these are typically going to be inside-out security assessments, right? So they're going to be looking at your source code or your binaries. And one of the advantages of this is it's going to be running against a non-running instance of your application. So this is something that you can go ahead and run before you actually deploy your application into production. And more often than not, these are going to be standalone tools. So when you look into some of these SaaS tools, right? So try and see if there are a few plugins with the IDE for the IDE itself, where you can have your developers install them on their IDEs so that as and when they're writing code, there are going to be a few security alerts that pop up and they can go ahead and fix those issues as early as possible, right? So if the security issues or the bugs are fixed before it's even committed to the Git repository, that's a great win for all of us. You also want to start tuning your SaaS tools for performance and for high fidelity tests, right? So as part of your threat model, right? So once your threat model is complete, if you're certain that a few attack vectors are not going to be possible, try and remove them, try and remove those checks from your SaaS tools. All right. So for example, if you're not using something like a SQL database, it probably does not make much sense to go ahead and look for something like SQL injection, right? So go ahead and remove that. That's a fairly basic example, but I'm sure you get what I'm talking about. And you also want to start using incremental SAST techniques, right? So I know that there are a few commercial tools out there that take multiple hours to go ahead and run a SaaS scan successfully. As an alternative, what you can probably do is go ahead and only scan the changes that have been made in the latest commit, right? So do not go ahead and scan the entire source code every single time. only the changes that have been made or only the files that have been changed in the latest commit, go ahead and scan only that, so that there are going to be incremental scans, and the scans are going to be performed a lot faster, and it's going to be a lot easier for developers to go ahead and fix issues as well. And false positives is something that you are going to have to deal with if your SAST is going to be untuned. Then we have source composition analysis, right? So because any application that you are going to be using, it's not going to be built from scratch. So you are going to be using a combination of multiple open source third-party dependencies and libraries, and you want to ensure that they are going to be secure in themselves, right? So your source composition analysis is going to be critical for finding vulnerabilities. It's going to be for maintaining license compliance. It's going to be extremely critical. So you can go ahead and start implementing like something like software bill of materials. So Cyclone DX is a great open source project, which I would highly recommend that you folks look into in case this is something that you are interested in. And at the same time, you also want to ensure that you're looking for outdated components, because the last thing that you want is some sort of a zero-day issue or a zero-day vulnerability that's going to pop up in your application, and you do not want your application to be vulnerable to it. So when it comes to the supply chain attacks itself or the supply chain security, your package manager is going to be the king, right? So it's completely going to depend on what your package manager is, how it performs, and nested packages is essentially gives you better coverage. And NPM audit is winning this approach, right? So if you compare something like Python and NPM audit, when it comes to Python, it just gives you a requirements.txt, but it does not necessarily tell you the dependencies of your dependency, right? So it does not tell you about the nested dependency. NPM, on the other hand, it's going to go ahead and tell you about that as well. And it's going to tell you some of the security implications in case you go ahead and install a vulnerable package. And at the same time, if you are going to be using multiple languages, it's going to be a pain to deal with multiple tools, right? So when it comes to SAST and SCA, especially for microservices or functions, it's always going to be a difficult thing, because typically speaking, all of these microservices, they are going to be written in multiple programming languages. And every programming language is going to have its own tool that it's going to run a scan against, right? So this is going to increase the complexity of running the SAST tool and integrating all of these tools as part of your entire pipeline. So it is extremely critical for you to identify the right tool. So with that, let's quickly look at dynamic application security testing as well. So when it comes to DAST tools, especially automating DAST tools, API is going to be the king, right? So API is going to be extremely critical for DevSecOps. And if you can handle the proxy and if you can handle the certificate issues programmatically, that's a great bonus. At the same time, you also want to be able to tune the rules and the scan policies, preferably programmatically as well, right? So if you can go ahead and tune all of these things programmatically, you can ensure that the scans that you're going to be running is going to be a lot more efficient and a lot more faster, because dynamic application security testing tools typically tend to take quite a while, right? So especially if you're going to go ahead and walk through the entire application and run an active scan, they tend to take a while. And you also want to export all of these results in parsable formats so that you can go ahead and essentially parse all of these results and then further analyze it if it's necessary. So with that, let's look at cloud native DevSecOps, right? So why even cloud native tech in the first place? So most of the hosting environments today are close to 100% cloud native, and it's going to help you save costs. There's no maintenance required, right? So if you are going to have something like Jenkins as part of your organization, you're probably going to have a separate team just managing Jenkins. But if you're going to go ahead and implement the exact same thing on cloud native technologies, you do not necessarily need a complete team to go ahead and manage something like Jenkins. And most of these cloud native technologies, they have powerful APIs, they have multiple tools that you can go ahead and start integrating it as well. And these cloud providers, whether it's Azure or GCP or AWS, they make it a lot easier to go ahead and start implementing DevSecOps. Right? So when it comes to DevSecOps on the cloud, we have Azure DevOps, we have GitLab CI, we have GitHub Actions. We can also start leveraging AWS Cloud Pipeline. And when it comes to asynchronous cloud native technology, we have serverless, right? So you can go ahead and start leveraging serverless to perform a few security scans. Then you have cloud native technologies like AWS Fargate or even step functions, which we are going to be looking into very soon. So there are multiple cloud native DevSecOps pipelines that you can start going ahead and implement, right? So especially with things like GitHub Actions and GitLab CI, it makes it extremely easy for you to go ahead and start integrating some of these security checks for your entire DevSecOps pipeline itself. So with that, let's quickly go ahead and get started with a couple of demos, right? So the first demo is going to be DevSecOps with GitHub Actions. I'm not going to be running the scans. I've already run the scans. I'm just going to showcase it to you because the scans obviously tend to take a pretty long time. And I really do not have much time left. So I have the scans run and I have the result. So in our example, as soon as a developer pushes the code to a GitHub repository, we're going to have a GitHub Actions right there, which is then going to go ahead and run a scan, right? So let's go ahead and quickly look at what is happening. So here I have DevSecOps with GitHub Actions, where I'm using Docker to go ahead and package my application. So if I head over to Actions, and I'll obviously have a failed build, which is intentional in my case right here. So if I head over to Actions and if I go to Workflows, I can see that I have DevSecOps with GitHub Actions that is failed. So in the build phase, what I've essentially done is I've gone ahead and I've built my Docker image, and then I've used an open source tool called Trivi to go ahead and run a scan against my application. And as you can see, it's found a lot of vulnerabilities, right? So this is an intentionally vulnerable Docker image, but you get the idea, right? So it's going to go ahead and find all of these issues in your entire build process itself. Then you also, at the same time, want to ensure that the source code that you're using or the components that you're using is a lot more secure. So in my example, I'm using an open source tool called PROIDEA, which is a source composition analysis tool for Python applications, and it's going to go ahead and perform a few checks. Similarly, at the same time, I also have a DAST scan with OWASP Zap, where I'm going to go ahead and initialize my container, which I built in my previous step. So I'm going to go ahead, launch my container, and then I'm going to run a Zap scan. And this Zap scan, again, I'm not running a spider scan. I'm spinning up the Zap proxy on port 8090, as you can probably see right here. It's going to spin up on port 8090, and I'm going to have a context, or I'm going to have a few security tests that are going to proxy through port 8090, right? So my script is essentially going to interact with my application with a few functionalities on port 8090, so that I don't necessarily have to spider my application and then run an active scan, which can be extremely time consuming. Right, so it's going to go ahead and perform a few tests, right? So it's going to perform a get method and a post method through port 8090, which is going to be through Zap, and then it's going to run all of these scans, and then it's going to go ahead and start writing all of these artifacts as well. Right, so if you want to go ahead and look into it, this is an open source project, so I have kept it public, so you can head over to my GitHub profile and you can look into it, right? So this is one of the great options that you can potentially look into. The next option is to start using something like AWS Fargate, right? So AWS Fargate essentially helps you run containers on AWS environment in a serverless style architecture, right? So you don't necessarily have to worry about where your containers are going to be running or what compute resources is going to be running on. You just define, hey, you know what? I want X amount of CPU and X amount of memory. I want you to go ahead and run this container. So we can start leveraging something like AWS Fargate and start using this to go ahead and start running scans as well. And this can be extremely useful to go ahead and spin up containers as worker machines, right? So it's going to go ahead and spin up these long-running jobs, especially something like a DAST scan or a source composition analysis scan. You can start leveraging Fargate and then have it communicate with multiple other services that AWS provides and go ahead and start running all of your scans. The advantage of this is that it is serverless, right? So you do not have to worry about maintaining the infrastructure. You don't have to worry about updating the entire infrastructure or none of that, right? So you just ensure that your container is up to date and it performs successfully. you go ahead and deploy it on Fargate, and that's pretty much it. So it's extremely easy to go ahead and replace, and there is no real necessary to go ahead and actually patch this. And you can, again, you can run this as persistent services. If you want a service that's constantly going to be up and running, you can go ahead and leverage Fargate. Or if you simply want to go ahead and launch a bunch of tasks, you can go ahead and spin up Fargate instances on demand as well. Right? So this is something that we are going to be looking at very quick, right? So the idea behind this is, as soon as there is a commit to something like GitHub, there's going to be a webhook which is going to trigger a SAST scan, and the result can be pushed into something like Slack. Once the SAST scan is complete, it can trigger a source composition analysis scan that can again be pushed into something like Jira or Slack again. Once both of these checks have been performed successfully, you can then deploy it to the staging environment, which is then going to trigger another DAST scan, which is going to go ahead and perform a dynamic application test against the running instance of your application. And then all of these results, you can go ahead and push it to your vulnerability management engine. Right? So this is something that you can go ahead and start doing. And honestly speaking, if you are going to be familiar with the cloud, implementing something like this is actually going to be pretty easy and straightforward. And you'll also want to start leveraging Lambda functions as well, right? So Lambda functions or functions as a service, these are going to be invoked based on events. And one of the advantages of this is these events or these Lambda functions, they can be triggered for a file upload in S3, right? So one of the examples that you can start doing is you can start using Lambda functions to go ahead and parse all of these files, right? So let's assume Zap goes ahead and runs a scan successfully and uploads the result file to something like S3. So as soon as there's an upload to S3, you can trigger a Lambda function, probably parse that XML file or the JSON file, try and remove all of the false positives, go ahead, generate a new report, and only then push all of these results into your vulnerability management solution. And this is something that you can leverage Lambda to do, right? So which can be a really awesome thing. You can also start leveraging Lambda to perform incremental scanning for code or the dependencies that we'd previously spoken about, right? So previously I mentioned that you can start using Lambda functions to go ahead and start scanning only for issues that have been changed, right? So suppose there's a new file commit, you only want to go ahead and scan that particular file itself. You can go ahead and leverage Lambda for that. And a combination of this is essentially what step functions is, right? So a step function, you can create something known as state machines, and you can have workflows which are going to be extremely useful with DevOps like tasks. And the advantage of this is you can essentially have conditions, right? You can say, if this, then go ahead and run that particular scan, right? So if this is going to be a Python file, go ahead and run a Python scan. If it's going to be a Golang file, go ahead and run a Golang scan, right? You can start having conditions as part of your step function, which is going to which can integrate both Fargate and serverless, and it can have decision-making capabilities as well, right? So this is a great thing that you can potentially look into. So again, with that, let's quickly have a look at the demo that I had set up. So what I'm going to do right now is in my AWS console, I'm just going to quickly look for step functions. And I've already deployed this, and I already have it up and running as well. Because again, I've integrated a Zap scan, and a Zap scan tends to take a while sometimes. But what I've essentially done is, as soon as there's a commit, or as soon as I trigger this, it's going to go ahead and run a Fargate task, right? So it's going to go ahead and run a Fargate task. Then it's going to notify if it was successful or if it was or if the job failed. Then it's going to go ahead and trigger a Zap scan. So, and then it's going to go ahead and notify me. Once all of these scans are complete, right? So after every scan is complete, at the same time, I'm also writing all of these results to a S3 bucket, right? So in my S3 bucket, as you can probably see right here, I have the bandit result file and the Zap result file. So what I can then do is I can trigger a serverless function based on the upload that has been created right here, trigger a serverless function, parse all of these result file, and then go ahead and start pushing it into my vulnerability management solution, right? So I do not necessarily have to deal with Jenkins or the DevOps team, which is going to be managing the Jenkins, and none of that anymore. It's just going to be a bunch of serverless functions and Fargate jobs. I do not have to worry about the infrastructure anymore either, right? So again, at the same time, you can go ahead and run tools like checkout to go ahead and start scanning your entire infrastructure as well. So when it comes to the entire security workflow with step functions, right? So my recommendation is to go ahead and start integrating it with where developers are usually going to be working, right? So whether it's going to be on Slack or Jira or even GitHub, right? So in our case, we essentially pulled our code from GitHub, ran our bandit scan, wrote results to S3, which then triggered a serverless function. Similarly, we triggered a Zap Fargate task, wrote all of the results to S3, and that triggered a serverless function. And all of these results were published and it was notified on our Slack channel as well. If you don't want to use Slack and if you want an alternative, one more thing that you can potentially do is start looking into integrating security as part of your entire pull request itself, right? So as soon as a developer creates a pull request, what you can do is you can integrate a GitHub webhook, which is going to trigger a SCA scan or a SAST scan, and then it's going to go ahead and write it back to the pull request itself, right? So again, let's quickly go ahead and look into my example right here. So what I've done here right now is I have two branches right here, right? I have the test branch and I have the main branch. So in the test branch, I'd gone ahead and essentially created hello.py, which was insecure. As you can probably see right here, it's using MD5. And I'm using an insecure variant of Python JWT, right? So this is vulnerable to insecure deserialization. So as soon as I committed this, I created a pull request, right? So I created a new pull request. And as soon as this pull request was created, what I've also done under settings is I've gone to webhooks and I've deployed a serverless function, right? So if you head over to my AWS Lambda, and if you look at Lambda right here, so I have a Lambda, which is going to look at the pull request, the files that have been changed as part of my pull request, right? So I have my Python SCA, which is going to be written to PR, SAST and SCA, right? So it's going to be two separate functions. As soon as it sees a change in my in my pull request, it's going to go ahead and trigger a scan, and it's going to write all of these results back to the pull request itself, right? So as soon as a developer actually creates a pull request, the scans are automatically there in a couple of seconds, right? So this literally takes less than 15 seconds for the results to pop up. This is going to trigger a service function. The service function is going to scan only the changes that have been made by the developer, so that it's going to be incremental scanning, and then it's going to go ahead and write the results back to the developer. So the developer can go ahead, look into these issues, and then go ahead and fix all of these issues as well, right? So this is something that I would highly recommend as well. The last thing is going to be our serverless pipeline, right? So again, serverless is going to be very similar to AppSec, DevSecOps, right? So it's honestly no different, right? So the way you go ahead and use or deploy serverless applications is going to be very similar to actual application security. However, your function as a service or your serverless applications, they need to have a good mixture of vulnerability detection and cloud configuration checks as well, right? So this is where tools like checkout come in handy, right? So checkout essentially runs scans against your serverless files, your Kubernetes files, your Docker files, and so on, right? So it's going to CloudFormation files. It's going to go ahead and perform infrastructure as code security analysis on your files itself. So in our serverless pipeline, what I've essentially done is I have integrated a tool called GitLeaks, which is going to look for secrets or sensitive, high sensitive information like secrets or AWS access IDs or secret keys, anything with a high entropy, right? So any high entropy strings, it's going to go ahead and look into that. Then we're also going to be running a bandit scan since our application is going to be Python. Similarly, I'm going to be running a PROIDEA scan, which is going to be a source composition analysis tool. And once my application has been deployed successfully, I am then going to go ahead and run a Lambda guard as well, right? So which is by the Skyscanner engineering team. So it's going to go ahead and actually scan my Lambda function. So in this example, I've actually gone ahead and used GitLab. And GitLab is something at least I personally tend to use a lot. So if you look at the pipeline right here, right? So what's essentially happening is I'm going to go ahead and perform a git leak scan. It's going to notify me if there are any high entropy strings or secrets in all of my previous commits as well. Then I'm going to be running my PROIDEA, which is going to be my source composition analysis. And then I'm also going to be running my SAST scan as well, right? So all of these scans are going to be running parallelly. Again, I can go ahead and browse all of the results as well. So if you look at the git leaks, I have my access ID and secret key right here, right? So it's going to tell me, hey, you know what, your access ID and your secret key are actually part of one of the previous commits. And then I'm going to go ahead and deploy the serverless function onto my AWS, right? So it's going to tell me, hey, you know what, this has been deployed successfully. And once it's actually been deployed, I'm then going to go ahead and run a Lambda guard scan against the deployed instance of my application. And this is going to give me a output as well. All right. So it's going to give me, and it's going to give me in a really neat HTML format, which I can then go through. It's obviously going to have JSON and XML as well, but it's going to scan all of my Lambda functions, which is currently on my infrastructure, and it's going to go ahead and give me a report for all of these scans as well. All right. So this is an additional way to go about essentially integrating security for microservices as part of the entire DevSecOps pipeline, right? So this was the last demo that I had. I'm sorry I could not run any of these demos live. That entire thing would have taken probably more than an hour, but I really wanted to showcase some of the implementation techniques that you can go back and start implementing, or at least start exploring within your organizations, and probably go ahead and implement some of these techniques as well, right? So with that, I have essentially come to the end of my talk, and I would like to thank you folks for being patient. For being patient.